Hey, so this is where I'm up to now with this particular project. So, um, in the last video, I was showing you how the gravity balls sort of just form their own um, little planets and stars and stuff just by virtue of the way gravity behaves. And so far, I have managed to make it a little bit prettier in that I've set up a small sort of testing program with a density slider and a zoom. So it focuses on a center point, which I'm going to call a singularity, and you can increase the gravitational pull of the singularity with the slider on the right, and you can zoom in and out with the slider on the left. Now, the singularity also has a property of it emits light, and for every ball that joins its grouping, it creates like a sun surface layer, which is the light emitter, and that will grow with the group of balls. So if I just start this. Okay, so in the top screen you can see the editor. That's the three-dimensional space in Unity, and in the bottom screen you can see what's the actual screen will be like in the game. Now if I move this gravity up just a little bit, because it gets very weird at higher gravities, you can see that it's starting to attract quite a few more balls quite a bit faster. Now in the top screen you can see the group moving off center of screen, and in the bottom it stays fixed. That's because the bottom screen is a camera that's attached to the singularity. In the top screen the camera's static, and you can actually see that it's moving. The yellow ball that's sort of consuming everything is what I've designated as the surface of the sun. That will have a texture on it. And if I move backwards, you can start to see how they're all interacting. I mean, the top screen shows you a bit more, but the bottom screen is a little bit more in-game how it will look. Now the reason why the balls on the bottom screen look slightly different to the ones on top is, firstly, they're not highlighted, they're just reflecting the light that's being emitted from the center. Whereas in this top one, they're actually highlighted with their own sort of selection thing. But I've only set the gravity to a fairly small amount. I've already got all these objects orbiting. I mean, there's a few out there doing weird shit, but that's what I come to expect from this. When it calculates all the velocities and all the different gravity pulls and everything, it does end up with weird shit as the norm. And that's probably formed a fairly stable little solar system. Now, my next thing is to have all of the balls that are in the sun element. It's to have them sort of go through fusion, and fusion will decrease the size of the ball and decrease the mass, but it will make them generally more dense, and then I will change what element they are. I've decided on 4 elements to start with, purely because those are, or the ones I've selected are probably more useful for sci-fi. I will probably add every single element in the periodic table as I make this more accurate. But for now, it's only going to be like sort of a token of what it could be. Now, you can see that this sun has its own momentum. It's moving across the grid in the three-dimensional space, and it seems static here. That's our solar system moving through space. This orbit, everything orbiting it is established based on the gravity of everything in the scene. So there's nothing that's pulling this sun, it's just the momentum that it's built up while it's been doing this. Now if I increase the gravity, which would more or less simulate fusion occurring, the density at the center of the sun would increase as you get heavier elements. And that's basically what this slide is going to do. It's going to increase the density in the singularity at the center and basically show the life of the star as it becomes more dense. Now if we move it up, you can see that it's already starting to pull in all the outlier objects. Everything's sort of being drawn towards it now. And it's important to do this slowly, because if you set the gravity too high, you can very quickly end up with things doing that. That little ball's just done a slingshot orbit because it's basically hit a momentum and an angle that means it's not going to hit the star. And we've already got new orbits forming from the balls just by changing the gravity. A lot of them have been sucked in, which is a nice little destruction mechanic, but for the most part there's still a few that can survive. So if we up the gravity a lot higher, you can see that suddenly it's drawing in quite a few more pieces. And if we look at this, you can see that even though all the balls are in there, if I lower this gravity, they stop moving. All right, but if I increase the density at the core, they start becoming very excited because they're pushing each other and they're moving and they're spinning and they're generating momentum. And you're getting these solar flares coming out where they're spitting out one or two balls at a time. At this level of gravity, and this is largely what I've been trying to simulate, the sun's actually behaving much like our own. I mean, it's spitting out material, that material is being drawn back in. If it's being spit out at a high enough velocity, it's not coming back. So that's simulating solar flares already. So that's a property of gravity. Those happen. Now, if I look in this list, I can see all of the clones, all the little balls. You can't really tell, but some of them are a little bit grayed out. They have exited the field that I've set up. So anything that gets 1,000 away from the sun is switched off, because it's never going to come back. It's basically been shot out at a speed that the gravity is not going to draw it back in. So we can see this getting much more excited. And then again, if we drop the gravity, it slows down. I think that's largely because when you have a more uniform density in a star, it actually is much more stable. When you start increasing the density at the core, which is what happens when you go through fusion, all the stuff on the outside, which is less dense, becomes more excited. And then that really, see, we're getting solar flares and stuff there. And I suppose that shows that this level of gravity, even though I don't have any orbitals left, is really what I need to simulate a proper star for this game. Now, if I go down to my bottom screen, the slight transparency lets me see the motion going on, so you can see how excitable the star is. There's nothing else in view, so it's not really important. Now, the interesting part is if I increase the gravity even further, I increase the rate of the solar flares and the severity. So you can see that this is really becoming excitable, having lots of explosions. Now, when it reaches a certain point, it's going to do that. And that has effectively shot every single ball, every single mass away from it because its gravity has gotten too high.